When you walk through a forest, you see a landscape of quiet, isolated giants. Each trunk stands like a solitary pillar in its own earth. We've long assumed these trees are locked in a slow-motion individual struggle. In this view, every plant is a private entity, competing with its neighbors for a limited supply of water and sunlight. Hidden just beneath the leaf litter, a massive society is operating in constant motion, rendering the silence of the surface irrelevant. Plunge beneath the soil, and you'll find that tree roots don't end in the dark. They intertwine with microscopic fungal threads, acting like biological circuitry. This is the Wood Wide Web. It is a massive, underground biological internet that physically plugs nearly every root system on the forest floor into a shared grid. The forest floor functions as an integrated metropolis, connecting thousands of trees into a single, unified system. On the surface, a massive mother tree might bask in the direct sun, while a tiny sapling nearby is trapped in the deep shade of the canopy, unable to photosynthesize enough food to survive. Rather than hoarding its abundance, the mother tree uses the network to redistribute its wealth. It actively pumps sugar and water down into its roots, injecting those resources directly into the fungal threads. These nutrients travel specifically toward the saplings struggling in the dark, bypassing other healthy trees to keep the youngest members of the forest alive. This behavior challenges the standard model of biological competition. Instead of maximizing its own growth at the expense of others, the tree invests in the survival of its neighbors. This targeted delivery system ensures that even those without access to the sun are kept part of the living collective. In this underground economy, a tree's excess resources act as a civic contribution to the long-term stability of the entire forest. This network also functions as a high-speed intelligence grid. When a swarm of insects attacks a single pine tree on the forest perimeter, the response is immediate. The damaged tree initiates a chemical distress protocol, signaling the exact nature of the threat. These warning signals radiate through the Wood Wide Web, moving through the root system at a pace that far outstrips the physical movement of the insects. When these signals reach neighboring trees, they trigger an internal defensive shift before a bug touches their leaves. Neighboring trees respond by manufacturing bitter toxins and bug-repellent chemicals, turning their own foliage into a hostile environment for the invaders. By the time the swarm arrives, the forest is no longer a group of passive targets, but a fully mobilized defensive front. This preemptive chemical warfare demonstrates that the network treats a localized trauma as a threat to the entire population. Between the distribution of essential rations and the sharing of rapid threat intelligence, the forest operates with a level of coordination usually reserved for a single body. As nutrients and data flow across root systems, the biological boundaries that define an individual tree begin to fade. The scale of this integration suggests that a forest is a single, calculating unit, a superorganism that relies on its connections to survive. The next time you walk through the woods, remember that you are walking over a constant, invisible conversation. Survival here is a collaborative project. Beneath the dirt, the trees are always talking, and they are never truly alone.